Hello guys, welcome back to the Tech Tutor. In today's video, we're going to continue our journey on operating systems, and we're going to start chapter 2 in today's video. So, chapter 2 is we talk about operating system structures, an overview of what we're going to go over, operating system services, user operating system interface, system calls, the types of system calls, the system programs, the design and implementation, structure, debugging, generation, and system boot. Without further ado, let's get started. So these are some objectives that we are aiming for by the end of this chapter, to describe the services in generally, and to see how what structure and deeper at a deeper level, at a much deeper level, how these structures are implemented. So coming to services, operating system services. So these services, as we know, operating system OS, they provide an environment for executing programs and services to programs and users. One set of OS services that are helpful to the user are the user interface. The user interface has things like there's many types of user interfaces. It could be a command line interface that we're going to see, or it could be a GUI, graphical user interface, or it could be a batch job. Coming to the program execution, we know a service that tells us that the system must be able to load a program into memory, and to run that program and execute either normally or abnormally. Then we have input-output operations like that we have with mouse or a keyboard. So a running program may require input-output, which may involve a file or an input-output device. Another set of services that we come to, like file system manipulation. So the file system, this is of particular interest because the OS really helps with read and write files and directories, and do all sorts of things with those files, right? Then we have communication between your computer and another computer over the network. Then we have error detection. So what if there's an error in one of the system services, or like an error that could happen in the CPU or the memory hardware. So we should be able to take appropriate action to ensure the correct and consistent computing of those errors. Then we come to resource allocation. So resources must be allocated to the systems to our system that's using it, right? So the resources like CPU cycles, main memory, file system storage. Then we come to accounting, to keep track of which users use how much and what kind of computer resources. Protection and security, there's a subtle difference between the two, protection and security. So protection involves ensuring that all system access to system resources is controlled. Okay, so all system access to system resources. But system security, it's from the outsiders. We're bringing the outsider element. When we require outsiders to, have user authentication, extends to defending the external input-output devices, right? You maybe plug in a USB, right? So ensuring that from external things that the system is secure. Just kind of an overview of the system. So you have multiple layers to this. You have a hardware layer, an OS layer, then you have the systems, the services layer, and above that you have the system calls, and you have the user interfaces, GUI, batch, command line, and user programs. So the CLI, this is a really important feature, really important user interface service. It is implemented in kernel. It's a way to directly communicate with the kernel. Sometimes you have multiple flavors of this. Like you could have like a bash, or you could have a command, a PowerShell or a command line interpreter. So most of the time the commands are built in, and if uh, yeah. So this is what kind of like a bash interpreter looks like. You could call it a terminal also, where you could track what's happening on your computer. You'd see what services are running. So yeah, so this is the closest thing it would be to if you want to communicate with a kernel. So user OS interface, GUI. So say you want it to be something user friendly, right? So have there's options for that. So Microsoft Windows as an OS, or it's in GUI, where it also has an inbuilt CLI option too. Apple's Aqua GUI interface. So when we say GUI, we say file, like where you can interact using a mouse, keyboard, monitor, where icons, as we see on our desktop, right? It represents files, programs. So yeah. Now coming to touchscreen interfaces, then we have uh, this is another form of user interface where you can have apps, right? As we know, apps, and you have uh, uh, mouse is not possible. You don't have a mouse. You use the touch screen, right? And you have a virtual keyboard. Yeah, so this is what it looks on the Mac OS. Moving on to system calls. So we covered user interface. Now we're moving on to the system calls. So programming interface systems provided by the OS, they are they're typically written in a high-level language like C or C++. Most of them can be accessed via an API rather than a system call. So API, application program interface, that acts like the middleman between a user and a direct system call. So it kind of acts as a link or a liaison, you could say. So Windows, the most common APIs are for Win32 API for Windows, POSIX API for POSIX systems, and Java API for Java JVM. So yeah, their system calls. So this is an example of a system call to copy content of one file to another. So you have the source file, then the system calls. There's a series of things uh, that a system does that goes behind the scenes, right? So you get the file's name, then you write the prompt in the file, right? Then you get the output file's name, you write the prompt to the screen. So multiple kind of else conditions, as you can see, then multiple loops that it will go into, uh, opening the file, closing the file, and terminating in the end. So this is a kind of example of a standard API, what this looks in Unix and Linux systems. Uh, so we have a return. Included, as we said, it's usually C or C++. We have a return value. Okay, so the return value will have the function name. So what the function should return, and then we have the parameters that go in it. So they could be an integer, a buffer, pointer, and an count. So a program that uses the read function must include the header file, as this file defines the size, a unist header. So if we, since this relies on this being included. Okay, so that's kind of like an overview of what an API looks like. Then coming to a system call, how do you implement this? So a number is typically associated with each system call. The system call interface that maintains a table index according to these numbers. So this interface invokes the intended system call in OS kernel and returns the status of the system call at any return values. So the caller, right? The caller needs to, and they don't need to know. They need know nothing. They don't need to know anything about how the system call is implemented. They just need to know how they put that in actual code, as you saw in the previous slide. How it's gonna be API. Understand what OS will do as a result call. So most details of the OS interface is hidden from the programmer through an API. So this is kind of the relationship. So the system call interface, right? That acts, as you can see, it acts like a middle section between the user mode and the kernel mode. So you have the user application. They send an open request. So this is kind of like the API here. They send an open request to the system call interface. The system call interface that sends a request. Using that API, maps it to whatever happens behind the scenes, and it processes that, and it returns it back to the system call interface, and that returns it to the user application. Right, so it's coming to system call parameter passing. So as we saw, we can use multiple parameters instead of just one. They could be parameters could be So its parameters are pushed are stored like a stack. So parameters can be pushed onto the stack by the program and popped off the stack by the OS. So parameter passing via a table. So there's some ways to pass the parameters. So this could be via a table. So you have a table here. So this is table X. You load address X onto the table, which goes, and also the system call. And then you use parameters from that table X to process that system call. And then you also have the code for the system call, uh, which is returned to user program later. So yeah, so there's many types of system calls. So creating processes, terminating processes, and abort. And there's a lot of like working with memory, with processes, dumping memory, a debugger for determining bugs. We're going to talk about the logs, managing access to shared data between processes. Coming to more specifically types of like sections, we have file management. File management, where we, as we saw, we create files, close files, edit them, save them. Device management, so like the devices that we were talking about, so requesting devices, releasing devices, writing to these devices. Then information maintenance, so getting like the time we see on our computers, right? Like what happens, like how do we get that, right? Time and date, the system's time and date, where is it local to, right? So we covered some of these sections, these services in the starting slides, but here we kind of go in more detail and see what actually happens. In context, the system calls. Communication, so like create, delete communication. So you could send, receive messages if the message passing model from client to server. Then you could also have a shared memory model to create and gain access to memory regions. And protection, so like how you can gain control access to resources. We said that it's an important feature, right? Like control access to resources. But security is what? Security is different because you control access from outsiders. So protection, get and set permissions, allow and deny user access. So these are some calls that you would see. Then you can think of it as like predefined functions for us. So for creating a process, Windows has create process, exit process, whereas Unix has fork, exit, wait, and it has it for each of these different services of protection, as we talked about. So standard C library example, where if you invoke the printf library call, right, it calls the write system call. The write system call. So the write system call is so the user mode we call printf, that goes to the standard C library. So it's kind of like the system call interface that calls the write, and the system call sends back processes and sends it back to the library, which processes and sends it back to the user mode or whatever the user interface is. So this is kind of like an example, so where you have single of tasks, how they're processed. So you have single tasks, and so what does the stack look at? How does memory look, right? At system startup, you have the kernel command interpreter, and you have free memory. But then once you start running a program, right? Remember, a program when a program that's running is called the process. Do you notice how you have lesser of the memory that's in the process now? And so yeah, so it's a single MS-DOS is an example where there's a single memory space. It loads the program into memory and it overwrites all but the kernel. So it could even overwrite a little bit of the command interpreter too. So when the program exits, though, then you have the shell. The shell is reloaded. This is another example of a shell Unix variant shell called FreeBSD, where you have multiple processes. So the shell executes fork systems. Fork we know is a create process, right? It helps you process. If the code executes the exec to load the program into process, and once it's done, the process exits with code equals 0, no error. If it exits with greater than 0, then there's no error. We'll continue our journey in chapter 2 in the next part. Stay tuned. Thank you.